will discuss about few concepts. So you would have heard about scalar quantity. What is scalar quantity? It talks about only magnitude. And what is a vector quantity, students? It talks about both magnitude and direction. We also have discussed about velocity. Velocity, what is velocity? Velocity is rate of displacement of a body. So velocity is equal to displacement by time taken, that is s by t. So that is a vector quantity because it has both magnitude and direction. We'll also discuss about acceleration. What is acceleration? It is rate of change of velocity with time. So change in velocity by time is called acceleration. Now let's get into the topic. What does the first law say? Every body continues to be in its state of rest or of uniform motion until an external force acts upon it. Let's understand it in detail. So, with the first law, there are two concepts which we'll understand, that is property of inertia and force. So, let's say that there is a book on the table. It will continue to be in that state of rest until an external force acts on it. Okay? Let's take an example of a car. Let's say that it is traveling at a distance of 40 kilometers per hour. It will continue to do so in a straight line until an external force acts on it. So in which direction should it act? It should act in the opposite direction. So there should be an opposing force of friction and air. So if there is no opposing force, what will happen? The car will continue to be in its motion, and if there is some force of friction, if there is a force of friction, it will stop. And if the force of friction is very small, what will happen? It moves a large distance and then stops. So what have we learned here? We have learned about inertia and force. What is inertia? That is the inherent property of a body to resist any change of its state is called inertia, and it has the same units as mass. So what are the different types of inertia? Inertia of rest. One good example is a book lying on the table. It will lie to be there until some external force acts on it. So there is a inherent inertia. Similarly, inertia of motion. A car will continue to move in a direction until something acts upon it. And there is also inertia of direction. So it will continue to move in the same direction until some force stops it. Force. What is force? Force is that which changes or tries to change the state of rest of a body or its uniform motion in a straight line. So just now we have learned that until unless a force acts on it, the body will not change its state of rest or motion. So what are the various types of forces that we see? In a day-to-day life, we see muscular force where we use to lift heavy bodies. There is force of friction, okay, that help us to move on smooth road. If there is no force of friction, we will skid. The car will skid. There is magnetic force, which is responsible for an iron rod getting attracted to a magnet. Then there is a gravitational force which pulls all the bodies towards the center of earth. Then there are forces of attraction like cohesion and adhesion, and also nuclear forces. Now let's look into Newton's second law. So what does the Newton's second law state? It states that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. With second law, we'll be learning two concepts. One is momentum, one is force. So the product of mass and velocity of a body is called its momentum. So how do we explain second law? For example, there are two balls which are moving in the same velocity in opposite direction. So what will happen when they meet? They come to rest. However, if the mass of one ball is heavier than that of other, what will the heavier one do? The heavier one will push back the lighter one. Also, it is possible for the lighter one to push the heavier one. In which condition it can do? When the velocity of the lighter one is more than the heavier one. Okay. Thus, the ability of a body to communicate motion to another body by impact, it depends on both what? The mass and the velocity. And this ability of the body is called its momentum. So, momentum is equal to product of mass and velocity. So, if V is the velocity of body of mass m, then momentum is given as m into V. Now, let's understand force. So, we have seen that if two balls of same mass and are moving with same velocity, they come to a state of rest. When say there are two balls of same velocity moving in opposite direction, they come to a state of rest, right? Now, why is it happening? It is because of force. So, let's say that let u be the velocity of body of mass m initially. Let's say some force has been acted on it and this has happened for time t seconds. So, what will happen? The body will gain a new velocity v due to the force. So, initial momentum is m into u. What is the initial momentum? M into the initial velocity of the body. What is the final momentum of the body? M into v, which is the new velocity gained because of the force applied for time t seconds. So, what is the change of momentum? mv minus mu. That is m of v minus u. What is the rate of change of momentum? mv minus mu by t, or m into v minus u by t. So, what is this v u minus u by t? There is a change of velocity. Rate of change of velocity is called what? Acceleration of body. So, rate of change of momentum is equal to m into a. So, force is equal to mass into acceleration, that is force is equal to product of mass into acceleration of a body, and the units are Newton. Okay. Now, let's get into the third law of motion. What does the third law say? Every action has an equal and opposite reaction. So, with third law, we'll be learning about opposing forces and law of conservation of momentum. For example, earlier condition we have understood that, let's say that there is a book lying on the table. Okay. So, the action and reaction have to be equal and opposite. So, the book rests on the table. What will happen? The former presses the table, which can be treated as action. Then, the table reacts and opposes the force in the upward direction on the book. This can be treated as reaction. So, these two forces are mutual and internal. Thus, action and reaction happen together in phase and act on different bodies. So, this is what is third law of motion. More in the next session. Thank you. Thanks a lot, and I wish you all the best.